Using microcontroller as desktop means, I mean, it's not a bad idea. I mean, I have a kind of so this is a Raspberry Pi 02W. So it's a microcontroller, and like one port is kind of it is used as for keyboard and mouse wireless, and another one it goes to kind of power cable, and I mean USB power cable, and there is a, I believe it should be visible, and there is a one port here, so that is for HDMI. So we can use a kind of a Raspberry Pi 02W. So it's really 02W. I can open it. So it is Raspberry Pi 02W. So it's a microcontroller, and it is quad core. So since it is a quad core, it is kind of tempting to use as a desktop, and the limitation what it shows is it is a kind of 512 MB RAM, so that is quite small. So it is different to I have a Raspberry Pi Zero. Okay, so this is the kind of old microcontroller. So okay, so this is a microcontroller. It also has a 512 MB RAM, and this is different in a way that okay. So this is the Raspberry Pi 0W wireless, and this is Raspberry Pi 02W. Okay, so the difference is that Raspberry Pi 0 is a kind of a single processor, probably around 1 gigahertz, and this is a 1 gigahertz, but it is quad core. So, but limitation is same. So both are 512 MB RAM. Okay, so that is the kind of thing that stops us to use it as a desktop. So can we use it as desktop? So that is a I mean full-fledged desktop. So it's not kind of a trivial desktop. It's a full-fledged desktop. So we can use it. So idea is that, but how? Means like if I am running kind of a Qt creator or Qt designer, so those kind of application, it will be kind of very slow. Or if I am running opengl heavy application, or web browser, or kind of a screen recorder, so those kind of thing, it is looking like a bit heavy for 512. I mean quad core processor is not the kind of a showstopper, so it is okay, but the showstopper becoming is 512 MB of RAM. So how we can increase the RAM from 512 MB so that we shall be able to use it as desktop? So that is the question. Now for the 512 MB RAM, so I think there is no provision here that we can. So this is Raspberry Pi. Better to show like it's open. So there is no provision that in any Raspberry Pi we can go and. So this is black one is the processor. So black one is the processor. Okay, and there would be somewhere, I believe, the memory. So the RAM. So RAM is 512. Okay, so it is not mentioned. So RAM is kind of 512 MB. So how we can increase? If I can't increase through hardware, then how it's possible to increase the RAM? Okay, so there is something called a kind of swap space. So if we see the operating system functionality, then whatever the, so like if we run our OS, then OS is nothing but mainly it's a kernel code. So kernel code would reside on the RAM permanently, so that is required. And then means typically it is not preempted, and user code generally they are preempted, so they will come to RAM or they will come to hard disk. So in the hard disk we have two region. One is a region that is our SD card. So I believe SD card is visible. So this is SD card. So, this is the place where kind of the program that is running that code is there. So it would kind of do kind of swapping. So from the memory to the RAM, it would do kind of a to and fro. So that is the concept, but still it keeps a swap area where exact mapping. So we can call it as a RAM cache. So exact mapping from the RAM to cache we can do, means to the swap area we can do. So swapping to and fro in a kind of a chunk of big memory is possible. So it is kind of a structured data we can make to and fro rather than byte wise what we receive from the main memory. So then it would be faster. So Raspberry Pi Bullseye is the OS that we will use. So it provides a kind of swap space it creates swap space on the hard disk, and that is 100 MB. So 512 MB is the RAM. So we can grow it by kind of 2 GB. So 2 GB swap space, I would RAM cache we can say, or swap space, and 512 MB as RAM. So I think it should increase the speed. Means it's a crucial. I mean anyone would find increasing the swap area on the internet. So it's many articles are available where we can increase the swap area, but it is kind of hit, means it is crossing a bottleneck. Means if you increase the swap area from the 100 MB that is the default to kind of 500 MB or 1 GB or 2 GB that is the maximum, it enhances the speed drastically. Okay, so drastically. So if we are able to enhance the speed drastically, then we can really use the great Raspberry Pi 2W as desktop. And if we are able to do, then it is really crossing a milestone. Means this much little computer, microcontroller, which can be used for device. That anyway, we are in procedure to bring the kind of a presentation of the device driver, and then so nice we can manipulate GPU, and then means for the HMI kind of communication and communication with the external world through the interfaces and through the PCI, we can use it as desktop and working desktop. So that way. using Raspberry Pi 2W as a desktop. So it is something that we saw, and then now we'll see, can we use kind of Raspberry Pi 2W for OpenGL kind of drawing. So like typically on x86 based machine, which are coming from kind of Intel architecture, and it is powerful. So there we run Linux, where we have kind of more than 2.5 gigahertz processors and 4 GB kind of RAM. So it supports OpenGL 3.3 shader, and probably Vulkan kind of graphic that is also supported beyond that. But on this Raspberry Pi microcontroller, certainly that much powerful GPU is not there. Only 512 RAM is there. So in that kind of CPU and GPU, we have to divide. Typically 64 MB we keep it for GPU. So in this hardware, it's not possible to run OpenGL 3.3 shaders. So we'll see that how we can modify our existing shader, and so that full-fledged OpenGL application, what configuration tweaking that we need to do, so that full-fledged OpenGL application we can run on this in this a little Raspberry Pi 2W hardware. So that we'll see, and it's quite interesting to kind of tweak the configuration in this hardware. In addition to what anyway we have shown that increasing the swipe area drastically means it converts the microcontroller to desktop suddenly. So after that we can run 3D graphics with this hardware, what all we need. So that will see.